All right, welcome. Today, we are going to crack the code on automated software delivery. We're diving deep into the world of Jenkins, which is this incredibly powerful engine that helps teams build and release software way faster and more reliably than ever. So let's get into it and explore how modern software actually gets made.
But first, let's just start with a big question. What if you could take the entire process, from a developer writing one line of code, all the way to that feature being in the hands of your users, and make it happen almost instantly, without any of those pesky manual errors? Well, that's the promise of the world we're about to jump into.
So, to really get a handle on the tools, we first have to understand the philosophy behind them. And in the world of modern software, that philosophy is all about the need for speed, but also for quality and consistency.
And it all starts with this term you've probably heard a million times, CI/CD. It stands for continuous integration and either continuous delivery or continuous deployment. Think of it as the blueprint for a digital assembly line. It's basically a set of automated practices that takes raw code from a developer and turns it into a finished product for users, all smoothly and safely.
Okay, so let's clear up something that trips a lot of people up, the subtle but really important difference between the two CDs. With continuous delivery, every change gets automatically tested and is made ready for release, but a human still has to push that final go button. On the other hand, with continuous deployment, that final step is also automated, so any change that passes all the tests goes straight to your users. No human intervention needed at all.
So why go through all this trouble? Well, the payoff is huge. You get your features to users faster, you catch bugs way earlier in the process when they're a lot cheaper and easier to fix, and the overall quality of your software just skyrockets because the whole process is so consistent and repeatable.
All right, so if CI/CD is the blueprint, who's the master builder? Well, that brings us to the star of our show, Jenkins.
Meet Jenkins. It is this massively popular open-source automation server. The best way to think about it is as the central orchestrator, the engine driving your digital assembly line. It's the tool that takes that CI/CD philosophy and actually makes it a reality by connecting all the different pieces and automating the entire workflow.
So how does Jenkins actually pull this off? It uses what's called a distributed architecture. You have the Jenkins controller, which is the brain. It schedules and manages all the work. And then you have one or many Jenkins agents, and these are the hands. They're the machines that actually do the heavy lifting. Compiling the code, running tests, all that stuff. And this whole setup is what lets you scale your operations like crazy.
Now this is where things get really, really powerful. Let's look at how Jenkins actually builds this digital assembly line for your code. It all revolves around a concept called a pipeline. The instructions for this entire assembly line are written down in a special file called a Jenkins file. And this is an absolute game changer because it means you can define your entire build, test, and deploy process as code. And when your pipeline is code, you can do all the same cool stuff you do with your app's code, store it in version control, review changes, and share it with your team.
Now, when you're writing these Jenkins files, you basically have two flavors of syntax to choose from. Declarative is the modern, structured, and way easier to read version, which is perfect for most things you'll want to do. Scripted is the older, more flexible syntax. It's based on the groovy programming language, and it gives you some serious power for really complex or unusual requirements. Honestly, for most people starting out, declarative is absolutely the way to go.
So, what does a pipeline actually do? Well, at its simplest, it's just a series of stages. First, you've got a build stage, where your code gets compiled. Next up is a test stage, where a bunch of automated tests run to check for bugs. And finally, there's a deploy stage, where the working application gets pushed out to a server. Simple as that. And if we zoom in on just one of those stages, let's say the build stage, you'll see it's made up of individual steps. First, it checks out the latest code from your source control system, like Git. Then, it runs a build tool, like Maven. And finally, it saves the resulting file. We call that the artifact, which is the packaged up, ready-to-run version of your app, so it can be used in the next stage.
And you know what the best part is? You don't have to just imagine what's going on inside this complex process. Jenkins has a really slick, modern interface called Blue Ocean. It gives you this crystal clear visual map of your pipeline as it's running, showing you exactly where things are going right, or more importantly, where they might be failing.
But here's the thing, Jenkins' real power isn't just about what it does by itself. It's about its incredible ability to integrate with the entire universe of developer tools. It's the ultimate team player. And all of this is made possible through plugins.
A plugin is just an extension that adds new functionality, like an app for your phone. And with over 1,800 of them available, Jenkins can connect to and orchestrate pretty much any tool you can possibly think of in the software world. How cool is that?
So, for example, the Git plugin lets Jenkins talk to your code repository. The pipeline plugin is the core engine that runs your Jenkins files. The Docker plugin lets you build and run your apps in containers. And a tool like the SonarQube plugin can automatically scan your code for quality issues every single time someone makes a change.
And this web of integrations just expands across the entire ecosystem. We're talking source control systems like GitHub or GitLab, container platforms like Docker and Kubernetes. You can even have it send a notification to your team on Slack when a build is done. Jenkins can truly tie it all together.
Okay, so let's tie this all together now. We've seen the philosophy, we've seen the tools. What's the ultimate impact of all this? Well, it lets us create smarter, faster, and way safer release processes.
At the end of the day, the payoff for all this automation is just massive. You're delivering new value to your users every week instead of every few months, which helps you outpace your competition. You catch problems when they're small and easy to fix. You totally eliminate that, well, it worked on my machine problem by having a consistent automated process, and it fosters incredible collaboration between your development and operations teams.
Modern pipelines are also getting a lot smarter about security. This practice called DevSecOps integrates security checks right into the pipeline itself. This means using tools to automatically scan your code for vulnerabilities. That's called SAST. And even test the running application for security flaws. That's DAST, long before it ever gets close to production.
And the deployment strategies themselves can get incredibly sophisticated. With something called a blue/green deployment, you can switch all of your users to a new version of your app instantly with zero downtime. Or with a canary deployment, you can release a new feature to just a small percentage of users first, minimizing your risk by making sure it works well before you roll it out to everybody.
So we'll end with this thought. Jenkins and CI/CD, they aren't really just about tools. They're about freeing up human potential. By automating all those repetitive, error-prone tasks of building, testing, and deploying software, we give our teams back their most valuable resource, time. So the real question is, how will your team use all that extra time to innovate and build the next great thing?